All right, welcome to the Bread and Chemistry channel. This video is on average versus weighted average masses. We're going to get into weighted average atomic mass here in a minute, but I first wanted to talk about the difference between just a regular average and a weighted average. So I'm going to use my car as an example. So I have a RAV4 here, 3,550 pounds is the mass of an average RAV4. And we have a RAV4 hybrid now. It's a new thing for Toyota, and that one weighs 3,800 pounds. So if I wanted to do an average of these two vehicles, regular average, you would just take your 3,550 plus your 3,800. Okay, get an answer of those, and we would divide by 2. Okay, so 3,550 plus 3,800 equals, divide by 2, we get 3,675. Okay, would be your average mass of, or average weight of a RAV4. Okay, but this is just the average weight of the types, right? If we're thinking about how long a RAV4 has existed, there's a lot more RAV4s on the road than there are RAV4 hybrids. This is something new from Toyota, okay? So, or at least it is from the time I'm making this video. So what we need to do is we need to consider how common is the RAV4 compared to how common the RAV4 hybrid is when we're talking about the average weight of a RAV4 out on the road today. Okay, so we have to take into account how common those are, and that's called the abundance. So abundance is just a fancy word again for how common something is. So let's say the RAV4 is 97.5% of all of the RAV4s, just the regular, okay? And then we have our hybrid making up the other 2.5% of RAV4s on the road, okay? So, well, those abundances can be used to find a weighted average, okay? This one is so much more common than this one. So instead of having an average where we're right in the middle of the two numbers, right in the middle, we're going to have an average that is much closer to the RAV4's mass, that 3,550, than it is to the 3,800, because that one is more common, okay? So mathematically, there's a couple of ways to do this. We're going to work with a way that uses a change here. We change from percentages to the word cars in this case. So we're just going to say we have 97.5 cars of the RAV4 for every 2.5 cars of the hybrid, which is true. 97.5% to 2.5% would come down to 97.5 cars to 2.5 cars. Now, I know you really can't have half a car, but the math is going to work for us if we do it this way, so just go with it, okay? 97.5 cars. Now, we want to know what all of those cars weigh together, because this is 100 cars. And if we know what all 100 of those cars weigh together, we can figure out the average mass of just one car. Okay, so I'm going to take my 97.5 cars and I'm going to multiply by the mass of one of those cars. So 3,550 pounds. Okay, and I'm going to take the 2.5 cars and I'm going to multiply by the mass of those 2.5 cars. So 3,800 pounds. Oops. Okay, all right, so let's get some totals here. We have 97.5 cars that weigh 3,550. Okay, there we get our answer in our calculator. But we only get to have 3 sig figs. Both of those only have 3 sig figs. So the 3, the 4, and the 6 are going to work for me, but these are going to have to turn into placeholders. So 346,000 pounds is what those 97.5 cars would weigh. Okay, then we have 2.5 cars of the hybrid at 3,800 pounds each. So 2.5 times 3,800. We get 9,500 pounds. Okay, and that actually has the right number of sig figs. All right, so we have 9,500 pounds worth of hybrid, 346,000 pounds worth of regular RAV4. We're going to add those together. What is the total of those 100 cars? Okay. Now, when we add, we have to consider sig figs as well, but let's just go ahead and get a calculator. So 9,500 plus 346,000. So 9,500 plus 346,000 equals, okay, well, that's a lot of fives. So 355,500 pounds. Okay, 355,500 pounds. Sig figs, though, if we look at this, I'm certain about that 9, I'm uncertain about that 5. If we look up here, though, certain about that 3, certain about that 4, I'm uncertain about that 6. If I'm uncertain about that 6, because that's my last sig fig up here, these are just placeholders, I have to carry that uncertainty down into my answer, and I have to be uncertain about the 100,000 or the thousands place. Okay, so this is going to round to 3, 5, 6, and then placeholder, 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 pounds. Okay, 356,000 pounds is the total mass of all 100 cars. So to find the average mass of one of those cars, I need to divide by the 100 cars. So 356,000 divided by 100, okay, and we get 3,560 pounds. That's the average mass of one RAV4 on the road today. All right, now we're going to take this and do this with an element now. Okay, I'm going to scroll that one off. And we have element X. So we don't know what element this is, but we know it has 2 isotopes, and we know their masses and their abundances. Okay, sometimes an element will have 3, 4, 5, 6 isotopes. We would treat it the same way. We're still going to take those masses, just like the mass of the RAV4s. We're going to multiply them by their abundances. We're going to change that percentage to atoms in this case. So instead of 30.83% abundant, I'm going to say we have 30.83 atoms that weigh this much. Okay? And we have 69.17 atoms that weigh this much. So we can multiply those two together and we can figure out what those atoms weigh. And when we add these together, we get 100 atoms. So first we're going to find out what all 100 atoms weigh, then we'll divide by 100 to figure out what the average atom weighs. So down here, we'll take our numbers, 62.930 AMUs times 69.17 atoms. Okay, and 64.923 AMUs times 30.83 atoms. Get some answers here. Let's see if I can type that into the calculator. Okay, 62.930 times 69.17, and we get 4352.868. I'm going to write small, 4352.868. Let's look at sig figs here. This has 5 sig figs. This has 4. So I only get to keep 4 here. Okay, so I'm going to rewrite that down here with the right number of sig figs. 4, 3, 5, 3, because that 8 rounds the 2 up. So 4353 is my first answer. Okay, now on to isotope B. 64.923. 64.923 times 30.83. 30.83 equals 2001.576. 2001.576. Okay. Now again, we have to look at sig figs. Over here we have 5. Over here we have 4. So we have to round that to 4. So this is going to round up to a 2. So 2 1,002 AMUs for that one. All right, add them together, we get 5, 5, 3, 6. That is what the total 100 atoms all weigh together, right? Divide by 100. Because we have 100 atoms, we want to figure out what one weighs, we divide our answer by 100. So we get 63.55. Okay? So over here, we get to write 63.55 AMUs. Then we go over to our periodic table and we can figure out what element it is. We find the mass number, not the atomic number, but the mass number that matches that the closest, and we figure out it's copper. Okay, this one, the sig figs were a lot easier than the RAV because we ended up with ones place, but remember when you're adding, whatever has the least decimal places is where we have to round to maintain that uncertainty. Okay, so practice the problems on your review. Hopefully one of those will give you some sig fig challenges.